Okay, we've seen in previous videos how we can optimize and adjust the camera parameters. I'm going to go ahead and use our optimization here to go to a reduced noise setting, which will give us a 4x4 bin image with close to maximum exposure, good signal to noise, so we can talk about indexing. Now, when we deal with indexing, there are a couple of things we need to be aware of. The first thing we're going to talk about are phases. We need to match this against a candidate phase. So we've at least set it up to say we're getting good diffraction patterns. So when we look about phases, there's a couple places we can see this. So we come to the pattern page, you'll see there's a phase section here. If we come to the scan page, this same phase section's here. If we come to the phase page itself, we see a similar section here, but it also adds a generate if we want to create our own phase. So this is generally considered a second level function compared to just loading. So I'm going to go back over to pattern, and I'm just going to say, again, we showed this earlier, but I can load. This allows us to load a file, but generally we get it through search. And again, I showed earlier, right now up on the top, everything's maybe present. So I could type in, if I wanted to find a nickel phase, I could find nickel. If I typed in aluminum, it will find an aluminum phase. And you can do things this way. We can search by chemistry. You can see with nothing in there, it starts to bring in all sorts of different materials that are listed. You can parse down things by crystal symmetry or not crystal symmetry. So if you only wanted, tetragonal results, this will search through the database and only find tetragonal results. And that's what we see here. Now we can also search different databases. Again, we typically use what we call our TSL database. That's 500 or so materials that we've optimized for EBSD. But there's also the American Mineralogist Crystal Structure Database. There's the ICSD, which is an option, and the ICDD, which is an option. And then once you've created or used databases, they go to either users, these are all the users on the system, or your own individual database if you have unique logins. What's important when we have this is if I click on my file, what it has is the crystal symmetry, so in this case it's cubic, the lattice parameters, and then down here what we call the reflectors, or these are the family of planes that have the highest diffraction intensity. These are the ones we expect to see in the EBSD pattern. So if we look down lower, there are other planes that match basic kinematical diffraction theory that will have some intensity, but these are going to be lower intensity. We generally detect the highest intensity planes. So the files in our TSL database are ones where we've optimized selecting these reflectors on and off that allow us to do a quick simulation that say, yeah, these patterns are going to look reasonable. And the reason that's important is when we do the indexing, we are going to measure the angles between the detected bands. And we compare those angles to angles calculated between these planes that are turned on looking for matches. And we'll talk about that in the next videos. But having the right structure is important to be able to find the right answer. And the reason I'll show that is, let's say we'll just pick moly silicide. We'll pick this one here, which is a tetragonal structure. And if I look at my indexing, not to give anything away, but this is going to be a pattern, my nickel indexing is going to be good. And we'll have a video that explains why this is good, but we have a high number of votes, a lower fit, and a high confidence index, and this solution looks correct. So if I toggle this solution on and off, the overlay looks correct, and our numbers show that that matches. Whereas if I select this other phase, you can see that the number of votes is lower, the fit is worse, and the confidence index is lower. You can see the confidence is actually 0 when we look at just this phase altogether, and it's red saying, hey, this better be suspect. I can toggle that solution on and off, and I can see that, yeah, sure enough, that does not match the underlying pattern. So we wouldn't want to try to index nickel as molysilicide because it's not the right structure. So that's one area of EBSD that's important, is having the right structure loaded allows us to index the pattern correctly.